Hey kids, welcome to lesson 5.3, comments and conditions. Adding comments to your code helps to make it more readable and maintainable. In the commercial world, software development is usually a team effort where many programmers will use your code and maintain it for years and years to come. Commenting is essential in this kind of environment and a good habit to develop, my friends. Comments will also help you to remember what you were doing when you look back to your code a month or even a year from now. Kids, I can't state this enough. You see how many problems I have on a daily basis. The only reason I can usually do anything is because of comments. If you listen to anything in this video, kids, listen to this. Comments are important. Your comments should be descriptive and meaningful to what you're doing. Just like how you name variables, same thing with the comments. In Java, we have 3 types of comments. The first one is the single line comment. We've used this a bunch of times. The next one is a multi-line document. And then the one after that is a document comment. The special characters, that's a // are used to mark the rest of the lines as a comment in many programming language. If the comment is going to be multiple lines, we use the / to start the comment and the reverse to end the comment. There is also a very special version of multi-line comment called the documentation comment. Java has a cool tool called JavaDoc that comes with the Java JDK. We'll pull out all of these comments to make documentation of a class as a web page. This tool generates the official Java documentation too. For example, the string class. Although you do not have to know this for the AP exam, it's a good idea to use the documentation comment in front of classes, methods, and instance variables in case you want to use them in this tool. And kids, all that document code is just saying is all those documents are going to be pulled out for just the comments for you to use. It's pretty helpful. We'll see that in a bit though, kids. Drag the definition from the left and drop it on the correct symbol on the right. Click the Check Me button to see if you're correct. Single line comments. Looks like we have a document, a comment, and a multi-line one here, kids. Let's just drag it over. Single line. Multi-line is this one. Well, the Java comment is this one. Let's see if I'm right, kids. Hey, I'm correct. The compiler will skip over comments, and they don't affect how your program runs. They are for you, your teacher, well, that's me, kids, and other programmers working with you. Here are some good examples of good commenting here, kids. And you've seen this a ton of times. If we were just making a new integer here, it looks like max 10. This is just keeping track of the max score. And then we go to our print method, and it's just telling me, hey, this is going to print out max. Point of this, kids, again, comments are to help you and your friends. Note that most IDEs will tend to show comments formatted in italics to make them easier for you to spot. There are some special tags that you can use in Java documentation. These are not required, but many programmers use them. Here are some common tags. The @author, @since, @version, @parameter, and @return. You've seen these up here, kids. Again, these are just some special characters when you're commenting it out. I like to think these as a watermark, even though they're not really watermarking anything, but at least tells where, who, and what it came from. As you write methods in a class, it is a good idea to keep in mind the preconditions and the postconditions for the method and write them in the comments. A precondition is a condition that must be true for your method code to work. For example, the assumption that the parameters have values and are not null. The methods could check for these preconditions, but they do not have to. The precondition is what the method expects in order to do its job properly. Really, kids, all that's saying is, hey, I have a string here. Are we getting a string back? Or are we getting some other sort of data type? A postcondition is a condition that is true after running the method. It is what the method promises to do. Postconditions describe the outcome of running the method. For example, what is being returned or what changes to the instance variable. These assumptions are very useful to other programmers who want to use your class and get the correct results. Here's an example of a preconditions, postconditions, and the @param. And if you remember, that's the parameter one from above in the turtle code that we used in the past for our drawings. And if you look here, we have a multi-line comment, constructor that takes X and Y positions for the turtle. Precondition is the parameter X and Y are coordinates from 0 to the width and height of the world. Postconditions is the turtle's placed in X and Y coordinates. So precondition just basically says, hey, here is the size of your world. That's what has to go into. Postcondition says, hey, did it go inside those? Parameters X is the X position. Parameter Y is the Y position. And then we just go down here. Key to this, kids, just from all of this comments, I can see exactly what they're trying to do right here. Try to break the preconditions of the turtle constructor below. Does the turtle constructor behave properly if you break the value of the precondition that X and Y are between 0 and 300? Try giving the turtle constructor X and Y values out of this range. What happens? Does the method give good results? Does it give any warnings? What about the T-forward method? Does it have any preconditions that you can break? Ooh, I like breaking things, kids. We're importing two things here. We have a public class turtle preconditions. We have our public static void main. We have our world, which is 300 by 300. It says change 0, 0 to some value outside of the 0 to 300 to break the preconditions and see what happens. We have our new turtle. It's being created at 0, 0 in the world. That means it goes X, Y, and the place we're putting it. We have a turn right, and then a show the actual world. And that's all we have there, kids. Well, let's try just breaking this real quick. Let's do a 400 by 400 and see what happens. You can see my turtle just pops down there, kids. Remember, our origin is up there. Let's try a negative number here, kids. See them up there. Well, let's do up here. We had to see what happens. Well, what happens, kids, is it just goes to the corner. We can't see it. Let's see what happens if we move the turtle forward. So let's just go T.forward, just like that, and hit save and run. Turtle can't move. So it looks like the turtle's stuck on the end no matter what, even if it should probably be somewhere over here. It's really just going to the end of the canvas. Doesn't matter if we move forward, backwards, whatever, kids. Once we're out of bounds, we're out of bounds. Does not look like we're getting any kind of errors, kids. And remember, there's two types of errors, syntax and logic. This definitely looks like a logic because the program's running, just not with the outcomes we expect, kids. So keep that in mind as we go forward. The turtle constructor's precondition is that X and Y should be between 0 and the width and height of the world. If it receives a value out of this range, it sets X and Y to the closest legal values that it can have, so the turtle appears just on the edge of the world. Kids, that's what we learned above. Similarly, the forward method will not allow the turtle to leave the world. Really, all that's saying is what we just learned from above. It'll go to the edge of where the canvas is and won't let us progress any farther than that. We have our check our understanding considering the following class definitions. We have a public class test score, a string student name, a double score, a double extra credit. Looks like we have a string N, which is student name, double S, which is a score, double EC, which is extra credit. And which of the following preconditions are reasonable for the test score constructor? Now, kids, look, it says preconditions. So I'm assuming it's going to be more than one here, okay? Precondition S is greater than 0. S is less than or equal to 0. Well, kids, This one is going to have to be, S is going to be greater than or equal to 0, because otherwise we'd have a negative number. So I don't think that one's going to work. Precondition score is greater than 0. Kids, this one isn't right because there is no score. There's an S. If S was greater than 0, well, that would work. And down here, we do have our S is greater than 0 and extra credit. Both of these are numbers. This precondition is right. Remember, we need 2, though. We have an S there. N is not the empty string. N is the name. And remember, kids, it's all or nothing, right? All or nothing with the parameters. So you need all 3. So that one is true, too. Student name is not the empty string. Well, student name here really is N. And while this seems a little confusing, kids, it is saying is above. Again, just like score, it's not student name empty, it is N. So just keep that in mind. Let's see if I'm right with my crazy logic, kids. Here we are. Just keep that in mind. Watch your instance variables and your constructors. They play an important part with questions like this. Let's consider the substring method in Java. The method has a strong precondition that its arguments refer to what's given in the string. So it's basically saying, hey, our preconditions are whatever's in our substring numbers, kids. And all that's doing is just pointing out indexes in our letters. The following code breaks the preconditions of the substring method and throws an index out of bounds exception. Kids, you remember that from a couple lessons ago? Can you fix the code by changing the arguments for the substring method to print out the substring? No. What are the preconditions for the substring method? Well, let's start with the first one. What's the precondition here? Precondition is the range of the word hello, kids. Remember 0, 1, 2, 3, 4. 0 to 4 indexes on there. So this one really preconditions is we get some number between 0 and 4. If we want to print off the LO, well, it's 0, 1, 2, and then we're going to go to 3, and 0, 1, 2, 3, 4, kids. We're going past the letter, kids, so we're going to go to 5 because 0, 1, 2, 3, 4, and we want to go to the end. We could also do our string hello.length, but we can also code it in like this. Let's see if I'm right. There we go. We went those 2 letters right there, and we just went 0, 1, 2, and then we print it off. Remember, starting at the 3rd, and then we go to the end. Let's just see what happens when we put 4 in here. What happens, kids? We just get the L. So just remember, we need to include the last letter. Note the method substring begin index end index has the precondition that 0 is less than or equal to the beginning index, and the end index is less than or equal to the length of the string index. Same thing I just said above there, kids. So again, your precondition has to be greater than 0, usually, and your end index is usually the length of whatever it is. Keep that in mind. Well, the following method is intended to return a substring starting at index I until the end of the string. For example, get I to end, and that's a 12-1, should return a 12. Which of the following is the most appropriate precondition for the method so that it does not throw an exception? Well, kids, again, what we're just looking to do here is the same thing that's above. Remember our precondition, it has to be greater than or equal to 0. And while this one does meet it, kids, we can always throw it on the other end, right? This is only taking care of one end, the low end, and we need to take care of the larger end. Well, this one just takes care of the larger end, so that isn't true. This one, that I is greater than 0 and less than the string length, well, that sounds right, kids. This one is wrong because, again, We don't want it to be equal to 0. We just want it to be greater than 0. So keep that in mind. Answer. Ooh, kids, I was a little backwards here. This one says it is 1. This one says it's 0. And remember, kids, it has to be greater than 0, not 1. So just keep that in mind. The answer actually should be D, kids. Whoops. Software validity and use case diagrams. Preconditions and postconditions are covered on the AP CSA exam. Software validity, testing, and use case diagrams, which are discussed in this subsection, are not covered on the AP CSA exam, but they're described here because they use preconditions and postconditions and are used by professional programmers. Determining the pre and post conditions helps us to test our code and determine the validity of our software. Software validity tests whether the software does what it's supposed to do before it is released. This is sometimes very important. For example, if the code is part of a satellite going into outer space or is going to be used in an emergency condition, we want to test it thoroughly and make sure it works before we put it into use. Good software testers try to actually break their own code. They try all kinds of inputs to see what the software will do because you never know what users will try or what conditions there will be. Never trust people, kids. So, always think of the preconditions of your code are and see what happens if you break them, and then see if you can protect or warn against that. Preconditions and postconditions can help us to design better software systems. Software designers often first draw a high-level use case diagram of a system that shows the different ways a user might interact with a system before they build it. Below is a simple use case diagram of the restaurant system. It shows 2 actors in the system, the customer and the staff at the restaurant. At the restaurant, in 3 use case in circles. A use case is a particular user interaction or situation in the system or software, and they often become methods in the program. We have our customer and staff here, and we see what happens between the two. Well, they both order food. The customer only eats it. Poor staff doesn't get to eat it. And the customer and the staff both deal with pay. This is just a use case diagram, kids. And if you get confused, well, these are super helpful. After drawing a use case diagram, designers write down the preconditions and the postconditions for each use case. Often a successful postcondition for one use case becomes the precondition for the next use case. For example, for the order food and eat food use cases, preconditions for order food, customer enters the restaurant, staff is ready to take their food. Postcondition for order food, customer orders the food, staff takes the order. Precondition for eat food, customer has already ordered food, staff has delivered the food. Kids, this is making me hungry. Postcondition for eat food, customer eats the food. And it's just seeing the ways they interact, kids. That's all it's doing there. What are some preconditions and postconditions for the use case pay for food from above? Remember, these are often related to the use case conditions order food and eat food. So what we're doing here is we are doing a precondition pay for food, right, kids? So we are doing a pay for food. And let's do a precondition pay for food. And then we'll do another one here because one is going to be the cust and one is going to be the employee. What are some conditions for it? Well, for the customer, they got to order the food, right, kids? Staff has to deliver the food. Maybe spell it right, though. And maybe eat food. How about for my employees? Well, for the pay for the food, maybe the customer gives money. Customer finish eating, stuff like that, kids. So you can see these pre and post conditions are usually leading into each other. And if we did Another one for leaving, we would be customer finished eating, customer finished paying, stuff like that. So that's all it is. Agile software development. There are many different models for software development. The waterfall method, developed in the 70s, is a step-by-step method where each phase is finished before the next phase begins. Well, this model has recently been criticized as not very adaptable. The more recent Agile development mode involves iteration, incremental development, where teams work in short 2 to 3 week sprints to completely develop, test, and release a component of the project to the customer for feedback. It is very adaptive as a project requirement changes all the time because of early testing and immediate customer feedback and collaboration. Really, kids, this is just saying back in the day, we used to just design it all out, throw it out and test it, then redo stuff. Now it's just saying, hey, do little parts, send it out, get feedback, redesign that, move on. And that's really the two different methods there. Another popular type of Agile method is called Scrum. There's a short video here, kids. We're not going to watch it in this video, but please take a moment, Google it or watch it. It really does explain it pretty well. There is this wake-up game. Kids, we may or may not do this in class. Again, I'm not going to go over this in this video. If we do it in class, we'll have a little talk there. Programming challenge, comments and conditions. Come up with 4 steps that a user must do to purchase a product. For example, a book on Java from an online store, and list the preconditions and postconditions for each step. You could pretend to buy something online to come up with the steps. You could use an online drawing tool like Creativity here to make our own use case diagrams, but it's not required. Don't forget to list pre and post conditions for each step. We can type in our answer below here, kids. All right, so we have to write down 4 steps to purchase. So the first one, well, we have to go to the website for the online store, right? And a pre for this one would be, well, open our browser, kids. And maybe a post for this one would be our account is active. Because kids, who likes to go somewhere and not be logged in when they're ready to buy and forget their passcodes? By the time you get it set, you don't even want it anymore. Next, once we get there, we have to search for the product that we want. Precondition of this, type in the search. So we're just looking for the search. And a post condition of that would be the list of products we see. So those would be all the products left. Number 3, add to a shopping cart. My favorite part, kids. A precondition for this is, well, we have an item selected. And a post condition for this is the item is in cart. So the first is we can just put it in the cart, and the second is we actually put it in the cart. Starting to see a pattern here, kids? Well, the next one, we got to pay for our stuff, right, kids? So the precondition for this, well, the credit card is entered. And maybe a post for this one is delivery date. And kids, those are the 4 steps a user must do to purchase a product and some pre and post conditions for each step. Again, kids, please don't just steal mine. Try your own. Here's a simple class called user. It can be used on an online store. Add some good commenting to this code before the class, the instant variables, and the methods. Well, kids, it pretty much tells us where to put stuff here. This ain't too bad. All we really got to do is put the stuff from above here. So really the above stuff, kids, is if we go all the way up here, woo, are these things right here, right? We're going to put the program we're using or language. We're going to do the author, the date, and what this program does. That's really all we're going to do down here, kids. So under my comments here, well, first off, I'm going to do some multi-line one, right, kids? So on this one, I'm going to do / and then 2 little ones there. And then to end it, remember, it just goes the other way there, kids. And what am I going to put in here? Well, this is going to be about the user. So I'm going to just do the name of my class and the language it's in, Java. And we're going to do the @author. And the author is Mr. Rhodes. We're going to do a date here, and then we're just going to do since. And today's date, well, kids, today is December 25th, 1999. Dooloot, dooloot, dooloot. Doing a little time travel here, kids. And we just got to tell what it does. This class keeps track of user names and, kids, user names and passwords. If we're looking through here, kids, this is exactly what this does here. So I think that's pretty good on that one. I'm going to come down here, give it a couple of spaces. And remember what we have to do here, kids. Instant variables and methods now. Well, what are our instant variables? Well, kids, that's right under our public class right here. I'm going to do a comment, 2 / instant variables for user name and password. That's all that's doing is just saying, hey, that's what's for the user. Coming down here, well, these are just our default values, kids. So I'm just going to put default values are assigned to, kids, I can't spell today, to an unknown user. Those are the worst, kids. Coming down here, well, we're just passing off our instant variables to our constructors, right? Let's just do instance variables are assigned values from new user creations. And kids, I forgot a slash here, and you saw that the new word came up. There we go. That's a little better. We have our print down here. We should probably put a comment out for that one too, kids. And this is a message displayed to the user. And we have our new user here. And I think that's everything, kids. We didn't have to do much. We added before the class right there. We did our instant variables there. And we did the methods down here. I think that's everything, kids. Let's save and run. Let's see what Runestone says. And if we look up here, kids, remember we had to use a couple of these types. It looks like I didn't quite use all of mine in the right. Let's just take a look here and see. Looks like we are missing some parts. Well, kids, I'll be honest. I think we got about everything we need here. Really did comment it out. They might want a little different things here. For example, you can put asterisks in front of some of these things. And I think we're pretty good, kids. If you turn this into me, I would be pretty happy here. I know we got our methods and our constructors there. I think they just wanted it done slightly different. But again, kids, all commenting is good commenting. So again, I would be perfectly happy with this if you turned it in. The important part is you know where to comment and you're leaving stuff that'll let you know what you're doing for the future. After that, we have our summary here, kids. Comments are ignored by the compiler and are not executed when the program is run. There are 3 types of comments in Java, which generate a block of comments, which generate a comment on one line, and then the Java doc comment, which are used to create an API documentation. A precondition is a condition that must be true prior to the execution of a section of programming code in order for the method to behave as expected. There is no expectation that the method will check to ensure preconditions are satisfied. A postcondition is a condition that always must be true after the execution of a section of program code. Postconditions describe the outcome of the execution in terms of what is being returned or state of an object. Programmers write methods to satisfy the postconditions when preconditions are met, kids. And all that is everything here, kids. Again, 3 types of methods, and pre and post conditions is really the heart of this lesson. As long as you understand those 2, you should be pretty good. As always, kids, if you have any questions, you can come see me. Otherwise, I'll see you on the next video. See you later, kids. Bye, bye, bye.